Hello and welcome to Microcap Tutorials. Today we're going to be doing constant current sources and talking about those. So we have a 100 milliamp source here and we have a 100 ohm resistor. And how current sources work is they are essentially like a contract. They're telling you that, okay, no matter what the kinds of voltage conditions or the things that I might have to do, I'm going to give you 100 milliamps in this direction of whatever it is that's connected to it. So it is a regulator. That's what a current source does. Now, as we have 100 milliamps going through the circuit, we can expect that these two values are going to interact to produce a voltage. So we can expect that 100 milliamps multiplied by 100 ohms is going to create a 10 volt voltage difference. So let's run a transient analysis. Great, here we have 100 milliamps of current going through it, and we have a voltage difference of 10 volts, exactly what we would expect. So that's one way that you can do your circuits. It's more of a Norton kind of understanding, is to have a current source on the left-hand side. But in most cases, you're going to have a voltage at some kind or at some point in your circuit, usually on the left-hand side. And you have we have the voltage source. Say it's for an automotive application. We put 12 volts there. And what we are now going to look at is the current source connected in the direction of the load. And so we're going to kind of model. It can be useful to model currents that may occur with the rest of the system. So we're going to set this to 10 amps, might be common for a 100-watt motor of some kind. We're going to set this to 20 milliohms. Now what's going to happen here is we have 12 volts over the current source, and that's not going to change, 12 volt here, but the difference between the voltage on the current source may change to be able to guarantee the fact that we have 10 amps running through this. So you would take your product as it's running, and you would take the root mean squared, or the RMS value of the current as it's running, and then you would plug that into the source and be like, okay, that's how the current is going to be performing as I run a normal operation, and that is the condition for what you're going to be simulating. Now, this lower value of resistance is often called a sense resistor, and it's designed with a very low but known resistance and with very tight tolerances, and the current that is going through this resistor will give you a voltage difference across it. This voltage difference is small. It's going to be in millivolts, so it's not enough to be able to dissipate a lot of power, so you're not going to waste a lot of energy, but it allows you to measure. And when you can measure something, then you can make decisions based off of it. So here we have out. This is going to be our output for this particular simulation. And this is often used in terms of a current source. So this is effectively an ammeter. I'm putting a current through a resistor, and then I'm going to measure the voltage. And that voltage is going to give me the understanding of how much current is going through the system. And I may put this next to a comparator. But for now, let's just look at this. So we have 12 volts, we have 10 amps, and then we have 20 milliohms. We can expect that this 10 amps multiplied by the 10 amps multiplied by the 20 milliohms is going to be 200 millivolts. So let's run that. This is more of a DC analysis, so we're not really concerned mostly about the graph, but here we have it, 200 millivolts. So if I wanted to imagine that this is a comparator of some kind, then, okay, well, on one terminal, I might set this to, say, 150 millivolt with respect to ground, and then this terminal here is going to connect to one side of the comparator, and then I'm going to get some sort of output that's going to switch between VC and VE depending on which one is greater. So if the voltage here at 200 millivolts is higher than the 150 millivolts, then I'm going to indicate some sort of true condition, and that might give me a way to detect if I have an overcurrent condition, and that's often how it's used, is to indicate overcurrent. And you may have more than one of these, and so with a different reference, maybe this one is at 250 millivolts, something like that. Go. And then you take the same sort of input off of this line. There's more that you would do to condition these circuits, but we're just kind of taking it as it comes here. Oops, we don't want that. We want this, and we want it to look somewhat presentable. Okay, so then now this is your level 2 error. So if the current passes through the level 1, you just get a warning, and you say, okay, slow things down. But if you go into the second circuit and your voltage starts to exceed whatever this reference voltage is, then it's like, okay, now you've got a real problem. And you could take the difference in time, and so you could take the rate between these particular moments, and then you could get a trend And then you could know, oh shoot, we're headed towards disaster. The current's going out of control. So this is one way that you would measure and make decisions off of it. So the last concept that we're going to talk about today is the symbolic representation. So right now we've been just using the shape groups of default. But if we change this to Euro, it's going to give us a European representation of that current source, which kind of looks like a Venn diagram with an arrow going through it. Sometimes in circuits you'll see it without the arrow, but that's what a constant current source is in the European convention system, is it looks like a Venn diagram. Go into the resistor, same thing. Change the shape group, Euro. It's very boxy looking. Go into shape group for the voltage supply. It sort of gets emboldened, and then there's a plus or minus associated with it. So if you have customers that are European, or at least the products have a dominance in those markets, then it might be nice to put your circuits in the European convention. And oftentimes customers or clients, they appreciate little things that you do for them that tell them that you're going to be responsible with the products and that you've given every bit of attention to the little things and that they can trust you. So just keep that in mind as you're doing your products and your circuits. So thanks for watching. I'll see you next time.